Hello everyone, I'm Chong, a PhD student at University of Miami, and this is a presentation using several slides for a poster validation for MODIS sea surface temperature retrievals using the Saildrone Uncrewed surface vehicle data. In a joint NOAA-NASA deployment, the 2019 Arctic cruises consisted of 6 Saildrones departing from Dutch Harbor, Alaska. The Saildrone is an advanced autonomous surface vehicle carrying a suite of scientific oceanic and meteorological instruments. Here is measurements from two of the Saildrones, Saildrone 1036 and Saildrone 1037, funded by NASA, are used for the validation of MODIS SST retrievals at high latitudes. The navigation routes are shown in figure on the left, and the instrument configuration of these two Saildrones is illustrated in figure on the right. So for the SST and other auxiliary datasets, firstly, we use the SST data from Saildrone. The skin SST is derived from data from two hydronics infrared parameters installed on the foredeck as a pair, one viewing the sea surface and the other directed towards the sky. Its accuracy has been proven to be sufficient by the paper given below, about 0.12K, after rigorous quality control. Subsurface SST is measured by CTDs and temperature loggers at different depths along the Saildrone's keel. And then we match the Saildrone SST with the MODIS SST data. As mentioned above, the skin SST from Saildrone are quality controlled based on the platform pitch and roll angles, and also removing those measurements close to sea ice. And we use the good quality MODIS retrievals with quality level 0 and 1. The temperature window between MODIS and Saildrone measurements is within 30 minutes, and the spatial difference is within 10 kilometers. And due to the different resolution, one MODIS pixel could be matched with multiple Saildrone measurements. Therefore, we only keep the closest one based on the time or spatial difference. And finally, we define the SST bias arrow delta SST as the MODIS SST minus the Saildrone SST. Now let's see some results. Here shows some statistics tables for both one-to-one time closest matchups and one-to-one distance closest matchups. And there are about 400 valid matchups between Saildrone and MODIS SST during the Arctic cruise in 2019. And the statistics for 1036 MODIS matchups are relatively good with pretty small mean and median. However, the MODIS SST biases are much more significant from the skin SST derived from measurements taken by Saildrone 1037, and this needs to be further studied. In general, we consider the distance closest matchups are more meaningful than the time closest ones, and it will be demonstrated later. And also, the statistics for MODIS quality level 0 and quality level 1 data are in reasonable pattern. with more inactive mean and median for quality level 1 data due to the longer atmospheric path length. So to study the significant statistic difference for MODIS SST matched with Saildrone 1036 and 1037, firstly we test if there is any systematic bias between the skin SST derived from 1036 and 1037. We calculate the statistics when the two vehicles were within 1 kilometer. And given the results in the table, no distinct systematic errors between the SS data from two Saildrones are found. So such difference of metrics are likely due to sampling issues, considering different atmospheric conditions experienced by 1036 and 1037. And from another perspective, we used the subsurface SST at 0.3 meter depth to compare with the MODIS SST retrievals. And the mean and median are significantly positive from 0, indicating that the SST depth is inappropriate as validation data due to the existence of diurnal warming due to the midnight sun during the Arctic cruises. And now let's see some aerial characteristics of delta SST. Figure A shows the histogram distribution of delta SST, which is close to normal. And figure B shows the scatter plot of the MODIS and Saildrone derived skin SST, with generally good agreement, but with few of large discrepancies. And the lower panel shows the time and spatial difference dependence of delta SST. Figure A indicates delta SST has a trend with increasing spatial difference, and this could be result from the large SST gradient area caused by oceanic fronts or some undetected clouds by MODIS cloud screening algorithm. Figure B shows the delta SST is insensitive within the time window. Therefore, we conclude that the distance closest matchups are more meaningful than the time closest ones. The upper right figure demonstrates delta SST has an active correlation with the amplitude of diurnal warming, especially greater than 1K. And this indicates that MODIS SST retrievals likely underestimate the large diurnal warming signals. The lower right figure shows delta SST is likely related to the air-sea temperature difference. Now let's make some summary. Firstly, the MODIS SST skin shows generally reasonable agreement with the Saildrone-derived SST skin SST. And the delta SST statistics using 1036 data are significantly different from those using 1037, and it is explained as a sampling issue. The delta SST shows an active trend as the increase of spatial difference between MODIS Saildrone matchups, but has no significant correlation with the time window. When the diurnal warming amplitude is large, the MODIS SST retrieval algorithm tends to underestimate the MODIS SST retrievals. And therefore, the atmospheric correction algorithm for MODIS SST at high latitudes necessarily needs to be further improved. And thank you for listening.